Few among you are studying very neatly, clearly, properly, and promptly. And if you go on studying, then certainly questions will be there. Now, out of the 16, 17 students present now, I am finding two questions. One question by Shubham and other question by Mandar. I discuss them one by one. A question by Shubham is why bonding molecular orbital is stable than antibonding molecular orbital. First, you need to understand what is meant by bonding orbital and other by means of antibonding orbital. Molecular orbital theory is dealing with the wave function, wave mechanics, quantum mechanics. That quantum mechanics, wave mechanics is completely different than our usual particulate mechanics or classical mechanics. The base I make clear to you. If in general sense I ask a question, positive charge and positive charge, what remains? Suppose I ask question to you, what will be your answer? Positive, positive, repulsion or attraction. One positive charge species is there, and nearby that if I brought positive charge species, there will be attraction or there will be repulsion. That's my question. Good, good. Nearly all you are saying repulsion. It's our basic and it's our understanding that positive, positive, there is a repulsion. But keep in mind, bear in mind that positive, positive repulsion in case of particulate thing. In case of wave mechanics, the case is different. Now, what that wave mechanics? A person is with some ideology, thinking process, thoughts. Other person is with his or her own ideology, thoughts. What do you think? Persons or personalities who have similar thoughts will have friendship, or those who have contradictory thoughts, opposite thought will interact, will come closer. Similar thoughts or opposite thoughts? Yes, similar thoughts, similar liking, then preferably they will come what the closer. Friendship can readily or easily form. That psychological aspect, mind aspect, thought aspect, thinking aspect is wave phenomenon. It is not particulate. It is not like the one thing came and collided or interacted with the other thing. So a difference in particulate mechanics, particulate means classical mechanics time being considered, and a difference in wave mechanics. Is it clear to you? Yes, very good. In wave mechanics, what is happening? Like things can attract. Positive, positive attraction. Negative, negative attraction. Positive, negative repulsion. It is wave mechanics. So we are considering electron in an orbital of any atom as a wave. Similarly, other atom, electron present in that atom or any orbital is also wave. Now, sinusoidal wave, if I consider, sine function, how it moves, how it progresses. Suppose a phase difference is 0. Sine 0, 0. Sine is a trigonometric function about which I am talking. Sine 90, maximum, that's a plus 1. Sine 180, again 0. So you are getting one hip, you are getting one crust. That's a behavior of wave I am talking about. So from 0 to 180, 0 to 0 through 1. So you are getting a positive region. That's our crust. If I proceed that function again, then 180, that is 0. Then you come down, say 270, minus 1, it's a minima. Then sine 360, that is what, again 0. So your lower phase, it is a trough. So one crust and trough. Likewise, sinusoidal wave. So wave, how we represent? Up, down and up. So up, maximum, stable situation means a linear situation, phase difference 0, then minimum, and then again what, the neutral position. That is our sine wave. What is the meaning of that? 50% it shows positive behavior and 50% it shows negative behavior. Here probability comes, chance of combination comes here. So if you consider any electron, then it can be in positive phase, it can be in negative phase. Possibilities are both. Means if I toss any coin, then two possibilities are there. Either I can get a result as a head or result as a tail. How much possibility is there? That I will get head half, or the 50% possibility. Probability will be 0.5 in terms of fraction. In terms of percentage, it is 50%. So So that probability concept is not that 2 times I toss the coin, so one time will be head and other time will be tail. No, this probability concept is applied for the large criteria concept, large data concept, all possible concepts. Here, many waves do remain, many atoms are there, many orbitals are there, and many possibilities are there. Among them, 50%. When you will go to reach, means suppose if you toss the coin lakh number of times, means large number, then 50% of that means 50,000 times it will be head, and 50,000 times it will be tail. Not only 10 times or 100 times I toss, 100 times if I toss, then 50 times head and 50 times tail. That may not be. So large number of data is necessary for which this concept is applicable. So, and it is here. So two possibilities are there. It can be positive or it can be negative. So now what you understood, the electron, whatever we are understanding in an orbital, that we are experiencing as like a wave. And a wave can have the function, and that function has the sign, and that sign can be positive or that sign can be negative. Up to here, basic idea clear to you? Very good. Majority of your answering promptly. Keep on replying. And if it is no, then also reply. I'll repeat. It is a case for the one atomic orbital. It is a case of the one electron. Similar will be the case for the other atom or atomic orbital for the electron. And they are mingling. They are interacting. For the sake of brevity, let me consider hydrogen atom. Electron is present in 1s orbital. It's a spherical orbital. It's a 1s orbital, and in that 1s orbital electron that we're understanding as a wave. This wave, which can be positive or negative, can interact with 1s electron of second hydrogen, which also can be positive or negative. And those are interacting. Molecular orbital theory is very wise. Wave mechanical approach is there. And all possibilities of combination we have to talk. Means it is like I was previously with the one coin where I can get head or tail. These two possibilities were there. Now I am with other coin. Here also I can get head and tail. Here also two possibilities. Now combining both, combining two coins, combining two wave functions, how many possibilities are there? How many ways I can combine them? What will the results? If I toss two coins, then how many probable results I will get? Possible results. When only one coin, two results were possible. Now if I toss two coins, then how many maximum possible results are there? Shubham, Akshata, Saurabh are saying 4. Only 3 students out of 16 or 17. Yes, Prathamesh, Joinita, all are saying now yes. 4, absolutely. Which 4? Head and head. Head on one coin, head on other coin. Second, tail and tail. Tail on one coin, tail on the coin. Means these are the same kind of possibilities. Head, head or tail, tail. Similar in case of wave function, positive, positive or negative, negative. Both have the same sign of the wave function. It's a one category. Possibilities are 2, but category is 1 here. Which category? Same category. Same wave function. Same sign. Positive, positive or negative, negative. Other possibility, unlike or opposite. One will be head, other will be tail. Or one will be tail and other will be head. Or one will be positive, other will be negative. Or negative and positive. These are the further 2 ways. But category is additional 1. That is unlike category. So total 4 possibilities of combination are there, but we can divide them in 2 parts. One part is like combination and other part is unlike a combination. Like combination means positive, positive, and unlike combination means positive and negative, or negative and positive. And in like also negative, negative, that also you like. So we are getting combination of 2 types, like a combination and unlike a combination. Are you understanding? Could you able to imagine the interaction between the orbitals with the wave function, like and unlike, same and opposite? Very good, very good. Now I am coming to the question of the Shubham about bonding and anti-bonding orbital. When like a combination occurs, positive, positive or negative, negative. Answer for my question, if positive wave and positive wave, positive thought and positive thought, if they come together, then there will be attraction or repulsion. Yes, yes. Oh, repulsion. Who is saying? Akshata. Akshata, we are talking about now wave mechanics. Therefore, the beginning only I said classical mechanics, particulate mechanics is of different, and now we are talking molecular orbital theory speaks about quantum approach, wave approach. It is not a particulate thing, it's a wave. Therefore, only that quantum numbers that you decided, no? Akshata, are you getting this point? Very good. So there will be attraction. So in one category, say first category, I am getting result as attraction. And similarly, you will understand other category, positive, negative, or negative, positive. There will be repulsion. Now I ask you the question. If there is attraction between the waves, if there is attraction between the concept of the atomic orbitals or aspect of the atomic orbitals, then their energy should decrease or energy will increase because of attraction. Energy decreases or energy increases? Okay. All you are answering increase. See, again, here you have to understand the basis. Thermodynamics gives free energy change or energy. Whatever these attempts are there of the combination, those are to decrease the energy, the non-directional bonding, and detailed study I did for that. Different example I had given. Profit means what, and that profit will be there if there is a decrease in energy. Stability will be there if there is a decrease in energy. If more energy, then unstable situation will be there. So even simple example, you say the water, if you take in any container and if you heat that, after heating, water will boil at particular temperature, or before boiling also you will finding water molecules are wobbling, they are energetic, so they are unstable. On the other hand, at room temperature, there's equilibrium. Water is cool, calm, and quiet. Still, there are vibrations, molecular vibrations do remain present. But understanding point of view, I'm saying when energy remains more, then unstable situation causes, less stable situation causes, and in order to have the stability, a reaction has to occur. Even the energetics of the reaction or mechanism of the different reactions, SN1, SN2, in the 12th standard also you might have studied, and now in graduation also you might have studied. Always what you have studied, the reactants they do combine and they achieve the state of activation energy, and once they achieve that minimum activation energy, then the reaction occurs. See, if you have to study, if you have to do any work, you should reach that activation level, then you minimum, then you will study, you will react with that content. Otherwise, if you are dead means in neutral, no energy, you are tired, you will not react. For reaction, minimum activation energy necessary, minimum. And when you focus with minimum activation energy or minimum energy, then only reaction occurs. If you pay the attention towards the instructions with minimum energy, so threshold energy, threshold focus, then you will feel, yes, now I am understanding. But if you are not attaining that minimum energy, you are doing any other task or somewhere by any means you are not able to focus, then you will find, no, it is difficult because you are not going to that activation energy. So the activation energy is unstable. So because of that, what you will tend, to react. We take food to get energy. Why we want energy? To do work, and after doing work we get result, and that gives the stability. And to get that result, work is necessary. To work, energy is necessary. Similarly, for reaction purpose, the activation is what necessary, and for activation, energy is what necessary, and then activation energy is what the higher. Now we are not talking about the activation energy, we are talking about the basic energy. Anything which is a higher level remains with high energy. It tends, natural tendency. Suppose if you take a water in a jug or in a container, at some particular height if you keep and you incline that container, what will happen? Water will come down. Gravitation force is there, but potential energy of that water in that jug and potential energy of water which fall on the ground is different. Potential energy of that water in the tanker, or you can say a tank remains at the in the house or building, and potential energy of the water which is coming on the tap or is filled in what the any container or the bucket is different. H rho g that you might have studied. Potential energy of the water in the waterfall at top is different, and waterfall down region is different. We are talking about that energy. So if that water is not going to get the stability by coming down, water will not come down. That energy is less at the lower situation, therefore it is what coming down. It tends to come down. So keep in mind, lower the energy, more will be the stability, and lowering of energy occurs by doing some reaction. So that reaction also remains solid, results also remain solid. So if you want to be a successful, thermodynamics is the answer for that. Gibbs free energy should be more and more negative, then reaction will be irreversible, spontaneous. Immediately you will get the reaction. When Neeraj Chopra was going to throw that javelin, at that time he should be energetic. He was so energetic, whatever the energy, whatever power is there, synchronization way by technique. It needs a technique. But technically, he has utilized that. Result is he lost the energy, but he has given the energy to the javelin, and that javelin went out. That's the result. That's whatever the 87 point something he has thrown, no, 87.58 meter. And because of that loss in energy, its energy decrease. So Neeraj, before throwing the javelin and after throwing the javelin, where is the stable situation? After throwing the javelin, a stable situation. But many times what happens for us, we do not try to get the energy and we do not try to use the energy. It's as good as we are dead. So you decide how should our life be. We have to get energy, we have to use energy. We have to come to the lower state. Again, it's a take and give mechanism. Only taking food, only getting energy has no meaning. Using that energy also has a meaning. Then only you will learn the secret of life, and that you will find in thermodynamics. The different laws of thermodynamics are there. Those are the secret of life. So here also is a thermodynamic approach. Lower the energy, more the stability. By means of resonance concept, some broadness I am giving to you, broad vision I am giving to you. Resonance concept, by delocalization of the electron, energy will decrease, and that will give stability. When you remain with anything, suppose if a regular college there, and if you brought a tiffin, and if you share the tiffin all together, if you eat, and alone eating, different things are there. By sharing, you get to a stability, some satisfaction you get. Of course, it depends on the situation. Just for example, I am giving. Even in family also, whatever the things are there, we do share and we remain united. We get some satisfaction. Likewise, chemistry also takes care of the chemical family. All atoms they do combine. All means the few selected atoms they do combine. And for the molecule, molecule is a family. Atom is an individual entity. Overall, stability is important. When you will get the stability in the family, when whatever the resources are there, if you distribute, you will get. That's the resonance concept. Delocalization of the electron. Electrons get delocalized. If you think about any child, then child, instead of remaining staying at only one home, the child goes to neighbors and in that locality moves. So that child feels okay at different places. So indirectly bonding also gets occur. Stability gets occur. All is a game of satisfaction. All is a game of happiness. Molecules also want happiness. Molecule also want stability. And happiness, stability aspect are studied in the chemistry regarding molecules. So we are talking about the formation of molecule. And during formation of molecule, if there is a decrease in energy by any combination, then that will give stability. A bond will form. So what should be the answer for the question? Energy, if attraction remains, then should decrease because attraction is resulting stabilization. Attraction is resulting stability. Attraction is giving happiness. Yes, students, is the basic. Are you understanding? Till now, actually, you should know these things. But you are not knowing means your approach to study the chemistry is not to the mark. This is a sign that you need to work more. Are you understanding what I am saying? Yes. So because of positive or negative, there will be the attraction, and because of attraction, there will be decrease in energy. And that orbital, which is formed by additive interaction means positive, negative, is called as bonding orbital. Or if electron goes in that orbital, then that electron will help for bonding, help to bring those atoms together, helps to bring their energies in such a way to give stability. That's the secret of formation of bonding orbital. Opposite is the case for antibonding orbital. In case of antibonding orbital, second category of combination. How? Positive and negative, or negative and positive. That combination will be there. And in such positive negative combination, there remains repulsion. Now I want correct answer. Due to repulsion, that antibonding orbital will be of low energy or high energy. Very good. High energy. Energy will increase. Will increase compared to whom? Compared to parent. compared to combining atomic orbitals. Relative to them, energy will be higher. For whom? Antibonding orbital. And relative to those atomic orbitals, bonding orbital energy will be lower. So it's a chemistry of decreasing energy and increasing energy. So by any means, if electron enters in antibonding orbital or electrons remain so huge that they have to go to the antibonding orbital, then that antibonding orbital will oppose for bonding, oppose to come closer. So in that chemical formation, molecule formation, there are the features where atoms are coming closer. There are the features by which atoms are going away. But nature brings them in such a way, first feature applicable is bringing them closer. That's a bonding orbital, low energy orbital. So electron will go in first low energy orbital. Electron will not go to the high energy orbital first. First will go to lower energy. And once lower energy is fulfilled, then there is no alternative. So that attraction also to particular limit, that care is taken by the nature. That care is taken by the chemistry. If electrons are extra, then electron will go to the antibonding molecular orbital. And if electron goes to the antibonding molecular orbital, then that will be opposition. There are the molecules where electron can go in the bonding orbital, say 2 electrons. Electron go in the antibonding orbital, say 2 electron. Number of electrons in bonding orbital and number of electrons in antibonding orbital are same. So attraction and repulsion is same. So result will be no attraction, no repulsion. Result will be no bonding. And surprisingly, molecular orbital theory explains it by means of concept of bond order. So I come to the basic question. Question asked by Shubham was, why bonding molecular orbital is stable or of lower energy while anti-bonding orbital is unstable? And because of stability, name is given. It helps for bonding, so bonding orbital. And higher energy orbital opposes for bonding, so anti-bonding molecular orbital. Shubham, did you get the answer for the question that you asked? Okay. Other students, what the question asked by Shubham and answer that I provided. Actually, in detail answer I provided. Basic approach I told. I said real, genuine approach. This chemistry will teach us about our life, will teach us about our satisfaction, will teach us about our happiness. Scientific approach will be here for the life. Very good, very good. But you have to look in that matter. You have to read more and more. If any concept remains, then you have to go deep in that. All these are thermodynamical consideration. Thermodynamics a topic in physical chemistry. So it is expected from you as a basic science student. In future, if you want to do the research where a lot of scope is there, then you keep habit of reading more and more. Go through the books, and now books are available on internet. Online books are available. Different courses also are available. Opt such courses where detailed information you are getting. But Shubham, you did a great job. Questions are very important. Because of that, you are learning more. Yes, I want to ask a free question to you. What Shubham did, what question Shubham has asked, and what answer I had provided. Do you think because of that your knowledge or interest or approach change, or there is a no change? Yes, that's a learning. When you will feel that you are learning and you are getting something and you could able to apply, that's a level of learning. Means only just reading and listening, and if necessary, if you feel, then you will answer the questions in the examination, and if you pass, then means learning. Your wrong approach. And keep in mind, here you are not coming only to learn the chemistry, zoology or mathematics, physics, such subjects. You are coming here to learn to live. Learning is a basic tool in our life. And that is very important. Science teaches in-depth learning. But your correlation, unless you apply your brain for that applications or utilizations, you will not learn properly. You will not enjoy. So learn that. And that how nobody will teach you. Nobody will teach you. You have to hunt that opportunity. You have to go on asking the question. Now Shubham, what he did over there, he got the question because he wanted to apply the concept. He could not get the answer, therefore he made him the question. So a person who is applying the learning approach always remains with the question, always remains. And the quality of questions decides he's at which level. And if no question is there, then 99% chances are there that you are not learning to the proper level. Okay, fine. I come to the question asked by the Mandar. Sigma and pi molecular orbitals. Okay. Actually, general way, what is taught to you, sigma means direct, head-on-head interaction, axial interaction, and pi means is a lateral interaction. In true sense, axial interaction is true, but molecular symmetry, the topic which is at TY level, when we will study then the concept will be the more clear. Axial means that axis, that's a point symmetry or the molecular symmetry axis. Along that axis, if combination is there, then the sigma bonding, sigma combination will be there. And if it is not, then we can say it is a pi. Perpendicular to that is a pi. Or is extent of interaction. Sigma, pi, delta. Sigma means strong interaction. Pi means little less interaction. And delta means further less interaction. So these are the cadres of the interaction. Strong interaction, strongest interaction means sigma. Lesser than that, pi. Further lesser than that, that is delta. So these are the symbols used to describe extent of interaction. Now in case of molecular orbitals, when s orbital remains, there's no question of sigma and pi. Sigma orbitals only obtains, because whatever the two spheres are there, two orbitals are there, they are common. Let they come in this direction, let they come or let they approach in this way or any other angle, let they approach. The extent of interaction will remain same. Extent of interaction. Mandar, listen carefully. Extent of interaction, amount of interaction will remain same. Let they come likewise, or by any way let they come. Extent of interaction, amount of mingling will remain same. So that's a maximum. That is sigma. But if you come to p orbital, p sublevel, actually more clear word is sublevel. In that p sublevel, three orbitals are there. Let you consider 2p sublevel or 3p sublevel or 4p sublevel. Any p sublevel, three orbitals are there. Can anybody answer which orbitals are there? Yes, Shubham, absolutely. Px, py, and pz. Means those three we can arrange in that direction. No, this time being considered just for the sake of understanding purpose. These axes can be changed. This left-right situation or right-left situation, consider x-axis towards you and me, y-axis up and down, z-axis. Time being considered. Actually, we should consider z-axis as a principal axis from the molecular symmetry. But I don't want to confuse you now. At this moment, this direction, left right direction, it is our x direction. Towards you and towards me, this direction is a y. Up and down, that is z. It is our consideration. So let you consider any p sublevel, 2p orbital of one atom, say carbon or oxygen or nitrogen, any atom. I am considering px orbital in this direction, py orbital towards you and me, pz orbital up and down. As like cluster means group of the p orbitals is there on this one atom, on these orbitals, in this level, 2p level. Similarly, other atom also will be with the cluster, but our definition of axis we can't change. This will be x in this direction, this will be z, and this will be y. When they approach in real point of view, you think on this direction. See, timing, let me talk about the px orbital. Px orbital of one atom and px orbital of other atom. During formation of molecule, atoms have to come together, atoms have to come closer. So if they come closer, so there will be overlap between them, x and x. This is one kind of extent of overlap. Yes, students, are you understanding what I am showing? Very good. So this is a one kind of overlap. Px overlap. But all other orbitals also are there. They also will overlap, no? So which orbital? Say pz orbital. Pz orbital of one atom and pz orbital of other atom. They also will overlap. So overlap means orbital is not like only line. It remains bulgier. It remains three-dimensional orientation when they interact. So they will interact in this way. Which orbital? pz orbital. How py orbitals will interact? Py orbital of one atom and py orbital of the atom, they will interact in this way. Means out of those three orbitals, px, py and pz, answer for my question, which orbital from your point of view has undergone strong interaction, strong overlap, more overlap? Okay, Gaurav is saying Z. Shubham is asking repeat. Okay, I repeat. Gaurav, listen carefully. Three orbitals are there. Px interaction is likewise. Direct py interaction is likewise. Pz interaction is likewise. Among these three interaction, which overlap is stronger? Okay, Shubham is saying all three. Any other answer? Gaurav, what's your answer? Z. Gaurav is saying PZ orbital will undergo strong interaction. Yes. What about the answers of others? If you don't know, say don't know. Okay. Now see, you have to apply. Means see, till now, means what I am finding. Majority of you are failing to imagine the things and applications. Means you are not trained your brain for that purpose. You may be graduate, postgraduate, or even you may be the PhD scholar. But if you do not use that brain, then from nation wealth point of view, depth point of view, or application point of view, you are not useful. So you have to learn that. So listen carefully now. I am showing the different kinds of interaction. Which interaction is stronger, that I was asking. Means what I am saying, there is a one vehicle going in this direction, other vehicle coming in opposite direction. These two are colliding each other. Means after accident, there that one vehicle merging in the other vehicle. Could you able to imagine an accident? Two four-wheelers are there, two taxis are there, and they are collided. They are coming with the same speed. They are collided, and now after collision, it will understand. Like situation is likewise. Both have interacted their space. Means front wheels went near the back wheels of other. That's interaction. That is axial interaction. There's a direct interaction. Direct is a one kind of interaction, is a one kind of accident. Other kind of accident, one vehicle going in one direction, other vehicle also coming in that direction, and both vehicles are with the same speed, but by any means they're colliding. These two vehicles are colliding. It's approach. Both are parallel, but by some means as such they are coming closer, and because of coming closer they are colliding, they are interacting. Now because of that, the doors of those vehicles are going to collide, and consider there also merging occurs, and one vehicle goes inside. Just it's a fantasy. What do you think? Where will merging horrible, merging to strong extent, overlap to strong extent, in direct interaction or lateral interaction? Yes, direct interaction, strong overlap will be there. That only I ask in the other way. PX vehicle, PX as a one car, other PX, and this PX and PX are interacting, and there is a overlap. X kind of overlap is there. That's a direct overlap. Other overlap, PZ is a one vehicle, PZ is other vehicle, and they are colliding, they are overlapping, they are merging. It's a second kind of overlap. Similarly, similar to PZ, you have to consider PY orbital of one atom and PY orbital of other atom. They are colliding, they are overlapping, they are interacting. My question was, among these three, which orbital will undergo more interaction, more overlap? Shubham has answered all three, and Gaurav answered Z. Yes, now your answer is yes. Gaurav, in book many times they say, let us consider Z as a bonding axis. So from that way they say that's a Z orbital interacts. But now I have changed the example. As per the problem, you have to change the answer. Then that is a by hearting. Now here, everybody has given the correct answer that the X orbital will interact strongly, strong attraction, strong interaction. Attraction not a fair word, because when interaction occurs, both possibilities are there, attraction as well as repulsion. Because two wave functions are there. This px is with the positive negative wave function, this px also is with the positive negative wave function, so their combination in the two ways, one bonding and other is anti-bonding. So because of this px interaction, you will get two molecular orbitals, one bonding, other anti-bonding, and this type of bonding, type of interaction is axial interaction, type of interaction is strong interaction, type of interaction is sigma. So we say two molecular orbitals are sigma bonding orbital and sigma anti-bonding orbital. Mandar, are you following what I'm saying? Yes, I'll come to the other questions later on. Let me continue my explanation. And if you think about the other orbitals, say py orbitals or pz orbitals, they are overlapping weakly. They are interacting weakly. But extent of interaction, listen carefully, extent of interaction, amount of interaction experienced by py and pz is same. So bonding orbital by py interaction and bonding orbital by pz interaction will be of same energy. Antibonding orbital by py interaction and antibonding orbital by pz interaction will be of same energy. Degenerate orbitals. Same energy orbitals means degenerate orbitals. So that will result pi bonding orbitals and pi anti-bonding orbitals. Previously what I discussed, sigma bonding orbitals and sigma anti-bonding orbitals. Now, what is the base of the bonding orbital? Bonding orbital decreases in energy, anti-bonding orbital increases in energy. So simple logic I apply. Bonding orbital, if there is a strong bond, pi bonding also is there and sigma bonding also is there. Answer for my question, which is strong, sigma or pi? Which bonding is strong, sigma bonding or pi bonding? Which interaction is strong, sigma or pi? Absolutely, sigma bonding is strong. So sigma bonding orbital, because of strong interaction, what is the criteria of bonding? Decrease in energy. So decrease in energy of that sigma bonding orbital will be more. Sigma bonding orbital, stable, more stable. Entry of electron sigma bonding orbital will give more stability. So first forms sigma bond, then forms pi bond. There are only few exceptions where sigma is not possible, so we are considering as pi, depending upon extent of interaction. Yes, sigma bonding orbital means sigma to px, lowest energy. Afterwards bonding orbital, which one? Pi bonding orbital, which is that pi to x and pi to py, lower than parent orbital energy, but higher than sigma to p. So in bonding orbitals, sigma to px should be of lower energy. Same logic, anti-bonding orbital. Anti-bonding orbitals increase energy. So where is strong anti-bonding? If here is strong bonding, anti-bonding also equally strong. So very strong anti-bonding, in px there is a strong anti-bonding. So sigma star to px anti-bonding orbital, that will be of highest energy. Lower than that will be the anti-bonding px and anti-bonding py, means pi px and pi py orbitals. So what's the energy sequence? Sigma to pz, stable, considerably stable, lowest energy. After that, pi to px and pi to py. Why pi to px, pi to py? Because pi is a kind of interaction, and to px to py names of those orbitals. After that, pi star to px and pi star to py. After that, sigma star to pz. That will be the energy sequence for the bonding and anti-bonding sigma and pi orbitals. Molecular orbitals means both bonding as well as anti-bonding. So what you learn from this explanation, sigma bonding orbital, lowest energy. Sigma anti-bonding orbital, highest energy. Pi bonding orbital, higher than the sigma bonding orbital in energy. Pi star means pi anti-bonding orbital, lower than the sigma star orbital. Means if I talk who is stable, pi star is stable or sigma star is stable, pi star is stable. This is a general approach, but there are exceptions. So low atomic number bearing elements, and for that one kind of MO diagram, and for other atomic number bearing elements, higher atomic number bearing elements, say oxygen, fluorine, say neon, you are finding the other kind of MO diagram. The reasons are there. If questions are there, I'll discuss. But now, question asked by Mandar was regarding the sigma and pi interactions. Mandar, did you get the answer? Yes, now I am asking question to the others. The question asked by Mandar and answer that I provided, is it clear to you? Yes, very good. Yes. Any more question? Okay, very good. See students, whatever I said that you are not studying, means your learning level is not that much satisfactory, don't take it negatively. Reality, whatever is there that I told to you, wherever you may be, reality we have to accept and we have to progress. And during your progress, if you come across any question, then for that purpose we are here. Otherwise, information you are getting in the textbooks, informations are available in the PDF files, literature is on internet is readily available. But reading between the lines, that's a concept that you have to grasp. And while grasping problems are there, we teachers are here. While applying problems are there, we teachers are there. So don't limit your learning. Broaden your approach of the learning, then you will enjoy study and you will enjoy life also. Means you will learn how to live. Study is one of the aspect. Are you following what I'm saying? Do you agree with me? Okay, do well. And if questions, I will be most happy to answer the questions. See what happened in this lecture, only 2 questions I answered. But while answering those 2 questions, lot of basics were covered. And I went to that much level because whenever I asked the question, you were not answering or you are failing to answer. Therefore, I went to that level. Let I go to the very bottom level, very low level, high level doesn't remain in the concept point of view. Let it be the school level concept. Doesn't matter. I'll go to that level and I will teach to you. But you should be eager to learn. Okay. Shall we stop now? Yes. So assignment is whatever the two questions are. One question asked by Shubham, you have to write that question and answer I provided. Question asked by Mandar and whatever the answer I had given, in short, you have to write. That notes you have to prepare. That will be the assignment for today's lecture. Is assignment clear to you? Yes, very good. Now I stop the recording.